Bionic Flying Fox. Festo is a German company that manufactures industrial equipment and automation systems. The robot you see on the screen is one of the projects of its specialists during its creation. The engineers, as you can easily guess, were inspired by the mechanics of the body of an animal, a flying fox at rest, as well as in a state of activity. The robot simulates the movements of a flying fox almost identically. Thus, it is able to hang upside down, clinging to a moving wand. The robot spreads its wings and alternates a flight phase with gliding. As material for the classrooms, the engineers chose impenetrable films, as well as lycra canvases, welded in 45,000 stitches. If you look at the material more closely, you can see the opium resembling beehives. Thanks to this special design, the robot can keep moving and does not lose its height, even if the fabric is damaged. It is worth noting that the developers have equipped the Fox with an infrared sensor system that transmits data about the surrounding space wirelessly. Thanks to them, the robot can fly in semi-automatic mode. Robert. Modern scientists and engineers are increasingly relying on animals to create their robots, especially birds. In 2014, specialists from the University of Twente, Netherlands joined the ranks of electronic bird breeders. Robert, produced by Clear Flight Solutions, is essentially a drone with the appearance of a falcon. The purpose of the machine is to provide a higher level of security at Edmonton Airport in Canada. The fact is that 8 million people are served here each year, and aircraft make 168,000 flights as of 2014. Birds were the main problem to be dealt with. As they flew into the airport, they would crash into the planes and hit the engines. Previously, lasers and sensors were used to control them, and the appearance of birds in the area was accompanied by a special signal. The Robert drone is a simpler and cheaper way to solve the problem. It mimics a bird of prey in the sky, and real birds do not approach for fear of the predator. Therefore, self-preservation instinct prevents them from flying to the airport. The speed of the drone is 80 km per hour. The drone flies under the control of an operator, but specialists are already working on the creation of an autonomous model. Bionic Wheelbot. Here we have another amazing robot created by specialists of the company, gesture of which we have already talked about earlier. Perhaps the main feature of Bionic Wheelbot is that, unlike its natural prototype, it will not scare even people. More arachnophobia. In addition, this spider robot, like other electronic animals from Festo, looks very attractive. He developed it was shown in March 2018. It is worth noting that the robot can move in two fundamentally different ways. In the first, to move forward. The machine uses 3 pairs of legs like a real spider. However, in case of danger, the robot rotates the legs to acquire the shape of a wheel. After that, it propels itself and rolls on the surface, reaching a higher speed of movement than if it walked with the legs in the usual way. The second mode of movement is also relevant for use in any situation where the surface underfoot is smooth. Bionic Wheelbot was created to show the possibilities that Scout robots will have in the future. Elum. For a long time, any underwater maintenance or inspection has been a complex, time-consuming and energy-intensive procedure. Fortunately, more and more engineers are working on robots that will make underwater work easier. Eloom, a flexible underwater robot developed by specialists from Norway. At first glance it is clear that the robot resembles a snake. The purpose of Eloom is to perform research work at the bottom of the ocean. It is noteworthy that the machine can stay at great depth for a long time, and does not need to rise to the surface by air. As a human being, the metal cylinders were designed so that Eloom resembles a snake. The fact is that this is the optimal shape for safe movement in a liquid environment. The robot is equipped with a motor that starts it. There are also cameras with which the operator can see what is happening underwater in real time. Another advantage of this robot is its modular design, thanks to which the customer can modify Eloom to his needs. For example, the machine can be equipped with tools for simple repairs. Grabster CR20. Mankind is working hard to explore the ocean floor and learn more about it. Grabster CR20 was created to patrol the coastal area of the Korean peninsula. The fact is that there are very strong underwater currents in this region. Therefore, swimming in these conditions is complicated, but the robot you see on the screen has no problem doing it. The powerful legs adhere to the bottom surface and grip the protrusions, so that the submersible maintains the correct position for its work. Like the name Grabster CR20, the engineers were inspired by a crab. This animal was chosen for its ability to move quickly both on land and on the seabed. Grabster CR20 is the brainchild of specialists from the Korea Institute of Ocean Science and Technology. It was first shown in 2016. Interestingly, the submersible is unmanned. Note the presence of windows that are not actually used to view the underwater world from inside. Illuminators allow a quick view of the sub's performance from the outside as it rises. The robot weighs 600 kilograms, and its speed is 1.5 kilometers per hour. It should be noted that the front legs can be equipped with manipulators to perform various tasks during underwater operations. Robot. To create this robot that mimics the movements of a salamander. The experts had to study X-rays of a real salamander's movements while walking on land or swimming. Perhaps that's why the resulting robot suit so closely resembles this animal. The robotic salamander was created by scientists at the Federal Polytechnic School of Lausanne. It was decided to print the robot's skeleton on a 3D printer. The robot is driven by electronic circuits operating under the control of the synthetic nervous system. Interestingly, the vertebrae of the robotic creature are smaller than the actual vertebrae of a salamander. However, this was done on purpose to achieve realistic movement with the available technology. The creators of the robot were pursuing a noble goal. Plurobot enables a deeper understanding of the locomotor apparatus of vertebrates. The new knowledge gained can be used to create better neuroprostheses for people.